Okay, so let's talk about session management. One of the things to bear in mind is that when we create a session, we're creating that session in a structure within our device called a session table. And that session table is maintained in RAM, in the memory of the device. So, of course, we only have a finite amount of memory in which to maintain this session table. So, it is possible to get to a situation where our device is so busy that we actually can be using up the available amount of memory, and we may be having delays, for example, in setting up new sessions. So within the device, we have a mechanism there where by default sessions automatically age out after a period of time. So if a session is not used, after a period of time, that session will age out and it will be removed from our session table. We can, however, go in and we can tweak this, we can change this, we can make that aging out process a little more aggressive so that we kind of manage our sessions a little better. So let's look at this slide here. The session hash table maintains sessions for a packet for packet matching and processing. When no traffic matches the session during the service timeout, the session ages out. So what we're saying is there is a default period set up which the SRX is saying, okay, well, I haven't got any traffic for this session for this particular time, therefore I'm going to pull that session out of the session table. Now, runtime changes during the lifetime of a session might propagate into the session. So routing changes, for example, will propagate into the session. Security policy changes will also propagate in and modify the session. So the session will be reset up in those cases. So what other things can we do to control these sessions? They are configured under the Edit Security Flow hierarchy within the device. Edit Security Flow. So we can get in there and we can start to be set up some more aggressive session timeout options. If we're finding that there are delays in setting up new sessions, this could be one of the issues. Things we can do is we can implement TCP sync checking. So essentially, we can make sure that the protocols syncing the sequence of these is strictly enforced. If it's not strictly, if we don't get the strict functionality of the protocol, we can drop the session. If we ever get a reset flag coming through, we'll automatically drop the session. If the sequence numbers or the numbers are not in sequence, we can drop the session. Or we can also say that if the initial TCP handshake exceeds a certain amount of time, in other words, if it takes too long to actually set up the session, so we've got when we're setting up a TCP session, the first packet goes through, we've got this three-way handshake, first packet goes through, when the first packet goes through, we set up a session. Now we're waiting for this three-way handshake to happen so that we can start communicating. What we're saying is, if that process takes too long, or it takes longer than we want it to, and we can get to set up what that timeout is, if it takes longer than what we want it to, we'll just pull that session straight out of the session table. And we'll just say, well, that process took too long. We'll just cancel that session altogether. Other things we can configure is this maximum segment size. Let me ask you a question. What would we be doing, or for what purpose may we want to go in and adjust the maximum segment size that we're allowing into a session, or to go through a session? What is it that we may be concerned about, if you put it that way, if we're in there wanting to change the maximum segment size? what is it that might be in our mind if we're thinking, gee, I need to go and I need to change the maximum segment size for my session? What is it that we might have on our mind? What is the situation that we may be trying to avoid if we're in there thinking about changing the maximum segment size? Anybody have any ideas about that? Maximum segment. What layer are we talking about, by the way? Talking about segments. We are talking about layer what? Segments are. See all this matters. You see all the stuff we talked about back in the CCNA. It's all coming back to you now. It's coming back. So I should remember that stuff. That doesn't really matter. Actually, it does. Segments, right? Layer 4. Okay, layer 4, transport layer, segments. And what does the segment size ultimately determine? The size of the segment ultimately determines the size of the packet, because the segment will go from layer 4 down into layer 3 and become the data in my packet. Okay, so the bigger the segment size, the bigger the packet. Now, is there any issues with packets that might be too big at all? Ever heard of a thing called maximum transmission unit, MTU? Okay, MTU is the biggest size packet that you can put through an interface. And you've got to put a frame on that packet. Okay, so basically it's the biggest payload that a frame can take. Is the maximum transmission unit. Alright? So, why might I have a problem with maximum transmission unit? Well, what if I'm putting a packet through an IPsec tunnel? Okay? I've got my standard packet size. Now what I'm going to do is I'm going to add an extra header onto it, because now I have to encapsulate it, my private packet, with a public header. So I've got another header. So I've encapsulated it with another header so that my private packet can go through the public internet. So now it's got two headers, the private one and the public one. I've now grown the size of my packet by the size of the header. I might have exceeded my maximum transmission unit, quite likely. If I'm putting it through a GRE tunnel, I could have exactly the same problem. I'll tell you where else you can have exactly the same problem. What if I'm using a PPPoE encapsulation? I could have exactly the same problem with that as well. If I'm using PPPoE and then putting it through IPsec as well, then I've got double trouble. Okay, so yes, the maximum transmission unit. What happens if I exceed my maximum transmission unit? What happens? Anybody? What happens to my IP packet? It gets fragmented. Right? It gets fragmented. Why is that bad? Why is that bad? Well, it's bad in two ways. Sometimes you have the fragment bit in the packet set to no fragment. So if it fragments, it just drops the packet altogether. Or if it allows it to fragment, then what has to happen is it has to take the fragmented packets at the other end and put it back together again. Okay, so you've got fragmented packets and being put back together. That takes a long time. So compared to not having fragmented packets, it takes a long time. So everything grinds down to a very, very slow speed. Okay, I mean very, very slow speed. So the way to overcome all of those problems is simply to go into Edit Security Flow and set up your maximum segment size to a size that is going to guarantee that your packets don't fragment. Okay, that's what you want. And I will say more often than not, you will need to do that. Okay, you probably will need to do this. So pay attention to that. Okay. Here's an example. of packet flow. We've got our private zone here. We have got we've got a couple of networks there in our private zone. Host B is sending traffic out to the internet. Comes in ultimately onto our device through interface GE001 and exits out on GE100 out to the internet. So it originates in one zone, the private zone, and it is exiting out in another zone, which is the external zone. That is a fairly typical situation. We're going to get into zones in a fair bit of detail shortly and really get our head around what they are all about. So, in this example, we have the first thing that the device has to decide is this packet part of an existing session? Now, we've already done the first path process, and we've now got a session table for this. Is it an existing session? If the answer is yes, it takes the fast path. If the answer is no, then we go through the process of setting up a session. So the next question is the destination reachable? In other words, do I actually have routing information to be able to route this particular packet? The answer is yes. We then go into the zone determination. Okay, which zone did it come in on? Which zone is it going out on? So we look at the zone information. Then what we do is we examine the security policies that are applicable to traffic going from that zone to the other zone. And we say, is this traffic permitted by our security policies? And if it is permitted by our security policies, then we're going to add it to the session table. So we're going to create a session in our session table, and then we are going to forward the packet. Okay, so in summary, in this chapter, what we looked at is traditional routing and security versus, if you like, what we really want to achieve in protecting our enterprise from traffic that's coming in. We discovered that the job of a traditional router is to forward everything as fast as possible. It doesn't really mind what that packet is. That packet is part of a communication flow. It doesn't care, it's not interested. All it does is it says, do I have a route for this packet? If I do, then away I go. I'm going to forward it. It will forward absolutely everything as fast as possible. Now, when it comes to our enterprise, are we just going to take absolutely everything that comes along and forward that straight into our private network? Absolutely not. We want to be very, very picky about what we allow into our private network. So we have a very different requirement when it comes to what we allow into our network to what a router provide us with. So we need something different. We need a different device. Looked at some of the current trends in networking. We also looked at the fact that our Juniper SRX device is both a router and a firewall built into one device. That gives us a lot of capability. And we looked at the logical packet flow through an SRX series device. Now, here's some questions for you. What type of packet processing do traditional routers provide? I'll give you a clue. It's either stateful or it's stateless. Which one was it? Okay, you've got a 50-50 chance of getting this right. Is it stateful or stateless? Traditional routers. Stateful. Guess. What does it mean? What does stateful or stateless mean?
allow everything or
No. No. What it means, if it's stateless, that means that the router, that the device takes no consideration of that packet's relationship to any other packet. It just looks at the packet and says, do I forward it? Yes, I've got an entry in the forwarding table. I forward it. End of story. That's stateless. Stateful means, looks at this packet and says, is this packet part of a flow? Does it have, let's look at the source address, destination address, protocol number, source port, destination port. Oh, look, that is the same as another packet or another series of packets which I've been sending is part of a flow. So it associates it with a flow. That's stateful. Okay? So, routers are stateless or stateful. Okay, this says less. This says full. Stateless. Okay, traditional routers forward packets based on an entry to the routing table. They don't care what other packets that packet looks like. They don't care. What type of packet processing do traditional firewalls provide? Ooh, easy one. Routers stateless. That must mean the firewalls are stateful. That's what they are. Okay, two main differences between the GNOS OS that runs on a GNOS security platform and the traditional GNOS OS. So in other words, we've just got a Juniper router operating system, and we've got the Juniper operating system that runs on our SRX devices. What is the difference? Okay, well, the operating systems that run on SRX devices are capable of stateful processing of packets. They also have built-in screen OS features. They also have built-in intruder detection and prevention features. Correct. Okay, so let's look at this question. So what I'm saying is you don't get that on a traditional router. A traditional router is purely packet-based, whereas the SRX operating system can operate in session-based mode. Alright, how is the first packet of a session handled differently to subsequent packets of the same session? The first packet. The first packet. So when the first packet comes through, the difference is we don't have a session for the first packet when it arrives. So we have to create a session. So the device has to create a session for that packet. So it has to go through the process of evaluating predominantly security policies. That's really what it's doing. It says, okay, is this packet allowed by our security policies? Coming on that zone, going out on that zone, what are the policies? Is the packet allowed? Then we set up a session. We don't have to ask the same question for every other packet that matches the session. We already know that it's allowed. We don't have to evaluate the security policies every single time. We already know that if we have a packet coming from that address to that address with this protocol, with these ports, it's allowed. We already know that. And I'm going to ask that question for every packet. So we ask it for the first packet, set up the session, set up the return flow, and then everything can go through the fast part after that. Okay. There we are. So that's the end of the first lesson. What we're going to do now is we are going to go in and take a look at zones. And I'm going to have to do a little bit of, that's interesting, a little bit of configuring here to get this all working nicely. Okay. Well, let me just get this organized here so that we get this going where we want to get it going. Yes, it's working. this right out of the way. That's better. Okay, so Introduction to General Security, Chapter 2. That's not where we want to be. We want to be down here. Zones. Zones. Get this totally sorted out here. This takes a little bit of juggling around to get this where I want it to be. Okay, that looks better. Is this going to work for me? Let's see. Zones. Move this PowerPoint slide up and down, or is it going to be a fixture? Okay. Let's get this working here, and we'll come back to it. It's working. Stop working. I might just call this quits for the moment until we get all of this actually working again. At the moment I'm staring at a black screen, so let me just get this sorted out and then we will